Hi, welcome back. In today's Knime's hands-on session, let us see neural networks for classification. So as usual, we will do this with help of a business use case. So the problem statement for today is predicting the customer churn for a bank. So as part of our Knime's hands-on, we will see how the data set is loaded into the system and do the basic data pre-processing, build a logistic regression for the base model as a base model, and then build a neural network and then see the performance of neural network compared to the base model of logistic regression. Okay, let's get started. Our dataset is in a CSV format, so let's take the CSV reader. As a first step, we should always configure the CSV reader with the data source. So this is our dataset. As we execute, now the dataset is available to us in a table format. Now the dataset has got 10 rows and 14 columns of different variables. Let's use a data explorer to get a high level view of how this data looks like. This is a variables, and we also have categorical variables with respect to the surname of the customer, geography, and the gender. As you see, some of the variables which are like numeric here in the data set, number of products, these are in the range of 1 to 4, but then these are not really numeric variables. Similarly, has card, this is represented as integer, but then this is a categorical variable. Similarly, is active member is also is also a categorical. Exiting, of course, we want this also to be categorical variable, and then these are all represented as numerical values in the given data set. So one way to change this numerical values into categorical is to do the transformation of the data by using the transformation tab. So we see the number of products are here are marked as integer, so we are transforming that into string. Same with the has card or is an active member is also categorical, and exited is also given as number, which is also a categorical. And because we are dealing with a classification problem, our target variable has to be a categorical variable. Okay, so this is how we have transformed data for our classification. Now we have transformed the numerical variables into categorical variables. But one thing is that the machine learning models would need numerical values, not the categorical variables. Of course, the exited value is going to be a categorical because this is our predicted target variable which we need to predict, and rest of the independent variables which are used for this prediction will have to be numerical values. For this, we will use one-to-many encoding, one-to-many node to transform the categorical variables, convert the categorical variables into numerical values using the one-shot encoding. So we are not doing anything with the surname. Exited is our target variable, so it has to be categorical. So for rest of these things, we need to do the one-to-many transformation for creating the dummy variables. Okay, now that if we look at our data, it has created the dummy variables. Now the columns are from have become from 14 to 22. Okay, now that see, if we see the geography, now for every geography, the categorical variable, there are three dummy variables that have been created with help of one to many one shot encoding. To remove the correlation, we will use the column filter. Customer ID cannot be is not needed for our machine learning model, so that can be removed. Row number is not required. Surname will not impact our model performance, so that can be excluded. So these are the fields, and then we see that no, there is a correlation between these three variables, so one of them has to be excluded. Okay, now we have done the basic transformation of basic pre-processing of all the variables. All the variables are in numeric format except our predicted target variable exited, which is string, and rest all zero. So this is what we would want. Okay, now we have done our basic processing, so let's quickly get into the creating our base model for the logistic regression. For logistic regression, we will use logistic learner. And before that, we need to partition the data set. So we will use table partitioner. And of course, as we have seen in our logistic regression video, we also need a scorer to look at the evaluation metrics for the logistic regression. Let me create an annotation so it is easy for visualizing what is being done with so many nodes. So this was our data pre-processing set. Okay, we have done data pre-processing. Now we are going to do a logistic regression. This is going to be our base. When we create our neural network, this will help us to see how the performance of the model is impacted when we have a neural network. Okay, now let us see. As we have seen in the logistic regression, we first needed table partitioner to divide our data set into 70/30, and then we will pass the training, we will use our training data set to make the logistic regression to learn from the data set. So those will be connected. The output of that learner will be passed on to the predictor, and the train and the test data will be passed on to the predictor to do the prediction. Once the prediction is done, to evaluate the performance, and we will use the scorer, and we will actually see the confusion matrix and the evaluation parameters like recall, precision, F1 score, and accuracy of using with help of the scorer. So let's quickly do this. Let's connect the table partition, configure. This time we will use the stratified sampling. Okay, we have passed on to the logistic regression learner for the model to learn. As part of the configuration, this is our target variable is exited, and these are all our numerical variables which are not correlated because we have removed the additional column with help of a column filter, and we were going to use all of them for our modeling. Now we will execute this. So the model has learned based on the training data that is given to it. Now the output of this is passed to the logistic regression predictor, and then we will use the test data also for the predictor to predict the data set given in the test partition. Let us configure if there is anything. Yeah, we would want to append the probabilities column. Now the prediction is done. Okay, so let us see the performance of this model by passing this by with help of a scorer. Now this is our target is exited, and then our we have to compare the first column exited with the our prediction predicted column. And then now we have got our confusion matrix and accuracy statistics. So if we look at this, this is our confusion matrix. True positives are 88, true negatives are 2130, false positives are 523, and false negatives are 252, and the accuracy of the model is 74%. If we also 74.6, 4.2 is the accuracy with respect to with help of this. Now this is our base reference that we will use and then build our neural network. And so let's start building the neural network now. Neural network now. In Knime, we have a very good neural network model that is called MLP, which stands for multi-layer Perceptron. This is a very popular model implementation of the neural network with a sequence of layers, connections of nodes with good activation function, and it is also a feed forward network of nodes. So let's pull in the MLP learner. Similarly, we also have a multi-layer Perceptron predictor as well. We know that once the predictor has done the prediction, we would need a scorer to evaluate the metrics. So, and another important thing that we need to remember in neural networks is about normalization. So, before passing the data onto the neural network trainer, we need to normalize the data. So that the normalization mode. The normalizer node and also the normalizer apply node. We would need normalization because we want to ensure that the data is in the certain range of 0 to 1 for all the input features that we pass on to the neural network. Okay, so let's build our neural, let us connect our nodes. So first, before passing the data onto the neural network learner, MLP learner, let us normalize the data. So we will connect the training data to the normalizer, see what variables that we these are all the variables that are we are using for the neural network. So we need to normalize all these input variables, and the type of normalization that we are using is min max normalization. So all the input variables features are going to be normalized within the range of 0 to 1. So let's execute and now pass on this normalized training data to the MLP learner. And then if we look at the MLP learner configuration, now there are this is the maximum number of iterations. This is like how many iterations that the machine learning will do to learn about the data. And then there are two other configurations that can be tweaked. One is the number of hidden layers and then the number of neurons per layer. So if we want to increase the complex of the model, it is better to increase the number of the hidden layers and number of neurons per layer. So for now, let us assume we are configuring three hidden layers. That means apart from the input layers, so we have three hidden layers to reach to the output. So there is like input layer, hidden layer 1, 2, 3, and then the output layer. So let's configure this. Of course, and our target variable is always the exited column, right? So let's configure that and then execute. So the MLP learner is learning, getting trained with the training data. Now the tricky part is that we need to use we used to use the normalizer apply to pass on this data to the predictor. We cannot do the normalization before partitioning because the normalization will tweak into the training data as well, test data as well. I'm sorry. So that is why we need to pass on the normalizer data to the normalizer apply and then pass on the training data, test data to the normalizer. And then the predictor will have the learning from the learner and the test data coming from the normalizer. So this way we are ensuring that we are not leaking the any normalization data from the training to the test. So this is very important that the normalization should be done only on the training data, not before the partitioning of the data. Okay, let us configure this. This is already configured. Let us execute. Yes, now the prediction on the test data is already done. Now let us connect the predictor prediction to evaluate the actual values and the predicted values to the scorer. Let's configure what is our actual predicted variable and the new column, the predicted column that we will have to evaluate. Once we, sorry, this is already configured. So let us execute. And now we have our evaluation metrics for the neural networks, the confusion matrix, and the accuracy statistics. If you see, again, the true positives are 268, true negatives are 2309, false positives are 343, false negatives are 80. And then you see the accuracy of the model is 85.9. Similarly, we can see other parameters like recall precision, sensitivity, specificity, FN score, etc. So as you see now, the accuracy with respect to your neural network is 85.9, whereas with logistic regression it is 74.2. So this is how we can say that no neural networks are much more powerful in giving a more accurate prediction compared to logistic regression. Let me enumerate this for quick recap. Was our prediction like uh, 85? Okay, let's a quick recap. We have our data for the customer churn in a CSV format. So we used a CSV reader, did the data pre-processing, used logistic regression to create a baseline for our accuracy, and then we have arrived at 74.2 as accuracy. Now we used the neural network. In neural networks, we need to use the concept of normalization, and the very important point is that the normalization has to be done after the data is split into training and test data, not before the partitioning. So once the data is normalized within the ranges of zero, with min-max normalization of 0 and 1, we pass on this normalized data to the MLP learner, which is the most popular neural network model that is built in Knime. And then here we can tweak the configuration parameters in terms of number of hidden layers and then hidden neurons per layer per each of the node. So once the learner has learned, we pass on that to the predictor and then the test data to the predictor for prediction. Once the predictor has predicted the actual and predicted values, we will use the scorer to evaluate the performance of the metrics. And as per the metrics that we have seen, we have achieved a good accuracy of 85.9 using neural networks. So this is how we do neural networks training in Nine. Thank you for watching.